This is the third video of Module 5 Vector Data Model. Last time I talked a little bit about data structures and terminology. Think of terms like feature class, feature dataset, coverage, shapefile, geodatabase. Understand the terminology and you'll be able to build your understanding as you go without stumbling over what the words mean. This video is going to cover selection and query, and these are two very important parts of working with vector as well as raster data. And so it will pay you heed to actually spend some time building your skills at using ArcGIS to do these types of things. So to that end, I've made some videos that demonstrate how to do selection and query using ArcGIS. Those demonstrations come from tutorial information in a book called Getting to Know ArcGIS Desktop. It's a good book if you want to get some more practice doing tutorial type things. You can go out and get this book, but there are 6 videos out there that help walk you through the process of using the tools and using the software to do these things. So my demonstrations in the lecture portion will be minimal. You can go out to these and do some better demonstrating. Okay, remember this from back in probably the first module. This is the knowledge hierarchy where we start at the bottom with data, which is just an atom of fact, and it has no context associated with it. When you associate context to the data, it becomes information. So the data is basically the where. It's a point, line, or polygon that's located somewhere in space. If we can connect it to the what, then we're getting closer to the information part of that hierarchy that we're going to be able to use to eventually develop knowledge and wisdom. Once we get the what and the where connected, we can start asking how geography matters in this specific application, and maybe even why geography matters. And so we can build our way up the hierarchy once we can connect the where and the what. Okay, flat files and databases. A flat file, you can think of that as a spreadsheet. It's basically a table with rows and columns. You can see that this table has information about parcels, the owner, the address, and the value. At some point, people figured out that storing information in a flat file sometimes ends up with some management issues in terms of redundancy and needing to store more information or more copies of information than you absolutely need. So people started using what are called databases, and one of the earliest databases was a hierarchical database that used what was called a parent-child relationship. Each parent could have many children, each child could have only one parent, and the database was set up so that you could work your way through and ask questions of the data based upon this structure. Another type of database that came along was called the network database. You can see that connections aren't necessarily hierarchical here. They're not parent-child, they're network connections. That eventually was replaced by what's called the relational database, which is one of the more popular database structures these days. And what that uses is tables that store redundant information in the tables that allow you to connect the tables together and ask questions that will grab pieces of multiple tables and give you the answer. This again is involved into an object relational database which retains the relational aspect of the data, but it adds object-oriented behavior which includes rules and behaviors that the data can perform. So this is the primary model that's used these days for databases, or maybe an object relational database, which might be something that would use a geodatabase in ArcGIS. Okay, so here we have a relational database that contains tables, forests, trails, recreational features, and characteristics. Now you can see where it would be redundant to store all the information about trails in the trails table, because I might have multiple trails that have waterfalls. I don't really need to be typing waterfall into this trails table everywhere it appears. And so it becomes a good management practice to split things into tables and relate them to each other. Okay, so I have a table. In our case, in a GIS, a table might be thought of as a feature class. So this is a forests feature class, so that would be polygon feature class. And tables have rows. In a database, the rows are called records. In the GIS, they're called features. Tables have columns. In a database, they're called fields. And in a feature class, they're called attributes. So again, with the terminology, row, record, feature, column, field, attribute, table, or feature class. Okay, here we have the same database again, and it uses what's called a primary key. And a primary key is a column or an attribute or a field that uniquely identifies each row or record or feature in the table. So for forests, this forest ID is what's called the primary key. So each one of the values in this column, field, or attribute has to be unique. So there's going to be only one number 1 and only one number 2. This is how you uniquely identify each row in this table. So using a primary key, we can relate tables together. There are 4 different types of relationships that you need to keep in mind. One-to-one, imagine parcels and addresses. Each and every parcel has one and only one address. You can make these into sentences. So a one-to-one relationship has source is related to one and only one target. It's one-to-one. Here's a one-to-many relationship. Think of counties and cities. So each and every county can be related to one or more cities. So each county can have more than one city. So it's one to many. We can flip that around and make many to one relationships. Assume we have a movie rental, so we rent movies and we keep track of the transition, the transactions, the rental transactions. So each movie rental is associated with a single movie. So this movie may be associated with that movie rental, may be associated with that movie, may have rented the same movie again, it's still that movie, many to one. Many to many, the most common example of that is students and classes. Each and every student can take one to many classes. Many students can be enrolled in each and every class. Many students can be enrolled in many classes. And you see how many to many works. Okay, here's an example from a GIS. We have counties, that would be a feature class. Each of these is a polygon. This is the primary key, the ID key. Each row is unique. Each county has a population, one population. So what we do is we store the county's ID, its primary key, in the population table, and we're able to link the two tables together and ask, what is the population change for this county? It can go to this table and grab this number and give us the answer, one to one. Here we have many to one. We have parcels, let's say, and parcels have an attribute or a field or a column associated with the zoning code. So this polygon might be medium density residential. There may be many polygons that are classified as medium density residential. The FID of each zone code can be associated with many parcels. So here we have many parcels have this single residential zone code. So how do we connect these things? Here we have a trails table, and we have one forest table. So each forest can have many trails. The primary key here, 1, 2, forest ID, gets stored in the trails table so that we know that Bryson's Knob is in the Nantahala Forest. We also know that North Fork, Cades Cove, and Appalachian are in the Nantahala Forest. So when we join these two together, we get a table in which each trail has the corresponding information of the forest that it's associated with. Join works for one-to-one and many-to-one. Remember that. One-to-one and many-to-one, you use join. This creates a new table. So the join makes a new table. Now this table won't persist. You have to explicitly store it, but it's going to make a new table that has all the attributes of both tables in it so you can ask questions. Relating tables. Here we have the same database again. We have forests, so we have two different forests. We have many trails, so each forest can contain many trails. Here we have one forest, but that forest is associated with many trails, so we're not going to be able to join it because we have one forest and many trails. The join won't work. This is a one-to-many relationship, so what we're going to do is we're going to use what's called a relate. And what a relate will do is, again, it'll store the primary key of the one table in the many table. And when you pick a single row from the one table, it will go in and it will select all of the rows in the second table that are associated with it. We're going to use a relate instead of a join for those one-to-many and many-to-many. So remember, many-to-one and one-to-one, use a join. One-to-many, many-to-many, use a relate. Relate isn't going to create a new table, it's just going to select things. So if I pick this using my selection tool and I create a relate, it'll go in and it'll pick all four of these in this table so that you can highlight the things that are associated with your source table, but it's not going to make a new table. When I showed you the join and I talked about not using it for one-to-many or many-to-many, I'll show you why that applies. Here we have forest, this is the one. Here we have many, which is the trails. So if we try to join these two together, what will happen is it will pick the first thing that it finds in this target table and it will join the attributes there and it'll neglect the ones that come after it. So this time it'll say Nantahala, it'll find Bryson's Knob, it'll make that join table, but it won't see North Fork, Cades Cove, or Appalachian, so those won't make it into the final table. So if you use one-to-many or many-to-many, you're going to get the first match only and your table isn't going to come out right. I think that this is pretty long for this video, so I'm not going to do queries and selections until another video, so that will come in the next video.